Built a fully pipeline voice sales agent for ABC Energy, including steps like data engineering, data cleansing. You basically take the model, LLM model such as Llama 3.1 8 billion, and you fine tune with locally. Actually, I use Google Colab. Uh, Using QLoRA, quantized low ranking adaptation to reduce from usual 16-bit floating point to 4-bit uh, floating point. Of course, I use the library Unsloth. Uh, there are other options. Unsloth is one such library, so you can fine tune it locally. So I fine tune that, and then also, of course, later I that was during training um, using SFTA supervised fine tuning. Also later at inference time, also I reduced the bit storage using a format GGUF, which is a GPT generated unified format as well. And once you have this LLM, how are we able to serve? You can serve through, well, locally Llama, but for enterprises, vLLM is preferred. So that's what I took the route, and of course, again use the Google Colab uh, uh, using vLLM, and of course, how do you reach the endpoint using ngrok, publicly publishable endpoint URL through which you make basically calls. Um, and how do I test it? I tested through you expose that through a FastAPI endpoint. As you can see, I'm serving. Here it is. You can see that I'm making a call to the publicly available endpoint chart, and then you can see that as well. So these scripts are actually generated, as you can see, data cleansing, synthetic generation, SGD, schema guided dialog. That was the data set combined with synthetic, and you split the data set into, as you can see, training, test, and validation. And you also cleanse the data, and you can see parts are cleansed. And then, of course, I also generated this DPO generated pair, but there was some dependency library dependency issue. I couldn't solve due to the time paucity. And then, of course, I did some evaluation on the fine-tuned LLM on the response of the LLM uh, Llama generated, which is adversarial LLM, and you could see this is this code for that. Um, Apparently, I also did README. Actually, you can see here uh, the whole README. Uh, you can see these are all some of the setup as well as s- performance report, design decisions. Why in LLM world, it's all about choices. There's a lot of choices, and you make some decision why, and you move on. If that doesn't come back, you can always pivot to different choice. These are some of the possible enhancements, and I guess my favorite is lessons learned, but also talking pain points. LLM is all about not so much about coding challenges, more of pain points. How do you circumvent those pain points? As you can see, uh, yeah, some memory issues, especially not so my favorite library mismatches. Stuff like that. That's why I had some of the libraries pinned to some specific versions. I also did a white paper so that some things which I couldn't do, uh, some of the design decisions you can see, uh, enhancements you could do further down the line. Treat this as MVP and then or POC, uh, and you can, given some time, you can always complete those enhancements. Um, yeah, so I think overall eval scores, as you can see, it's initially it was low range 2 to 4. Then I had increased the data was imbalance between the uh, schema guided dialogue data set versus synthetic. Initially it was very less than 1%. Then I increased to around 2.5%. Then you can see and of course LLM was fine tuned using QLoRA supervised fine tuning, and then also used GGUF GGUF format for the memory reduction, and then you use the GPT to evaluate the Llama generated uh, responses, and this is what I found overall around 6 point, close to 7 actually. That's not bad. Well, we can increase the data, and you can definitely improve the eval scores. And also, instead of DPO, which is a uh, direct proximal optimization, preference optimization, you could even use RLHF, reinforcement learning through human feedback, to increase, um, yeah, to increase the eval scores. Thank you.